Hello everyone, welcome back to the session. I hope all of you are well and fit and taking good care of your health and studies as well. So in our previous session, we discussed about climatology, and now we are starting with the oceanography. In oceanography, you will get to know that how water is a main, we can say, the interplay of all of the factors which we discussed in climatology. You will get to know that what manner there is a temperature action on water, and how that water will actually affect all the other kind of activities which we have covered as of now, but I'll make a linkages with that, so that you'll have a clear cut understanding when it comes to the oceanography. So oceanography is all about water, and the form of water which you used to see on our earth surface. That water is mainly confined in five major oceans. Ocean also contains sea, ocean also contain bay, for example. And we have a ocean ranging from Pacific Ocean, Indian Ocean, Atlantic Ocean, Arctic Ocean, or Northern Ocean, you can say. And you have a Southern Ocean, or to some extent that can be referred as Antarctic Ocean as well, Antarctica Ocean as well. Like, that is just a name to those different water bodies which are actually being found. And I hope you are aware with respect to the latitudinal variation of all of these water bodies, and accordingly there will be some sort of heating and cooling of these major oceans. Let's start with the oceanography. And like, as I told you, oceanography is all about water, and water is very much essential for our life. Water is very much essential for survival. Water is actually very much essential for agricultural activity, for industrial activities. In order to make a functional GDP, or to make GDP functional for a period of time, you need water. So water is very much essential commodity, if I say, in our today's world. So that would be correct, that would be appropriate. Now, the water which we used to see on our earth's surface, now that water is basically 97% of total water which is there. 97% of total water which is there. So that water is actually confined in these ocean. Only 3% of fresh water is there, and that 3% fresh water is available for us to consume, because it is not like ideal to consume or use this ocean water for the daily purposes, or even industries cannot use this ocean water, because in the ocean water we have a salts, or we have a salinity. And if you have a high saline water, that is not usual. That is not advisable to use that water, because it will come with its own constraints. So there are problems when it comes to the saline water, which is not usable. However, with the desalinization technology, you can use that ocean water. So 97% of earth's water is mainly confined in those five oceans. And here, for example, 71% of earth's surface is covered underwater. Almost 70%, you can say. So 70% of our earth's surface is covered with water. So it's a big area, I would say. Only 30% area is there where human used to live, or like where you will see mountain or whatever, geomorphic actions, the topographical form, the particular, we can say, landforms which we have discussed as of now. They are mainly confined on that 30% area, roughly 30% area, and 71% area is with respect to the ocean. Now when it comes to the water, I told you that water is very much essential, and similarly water is very much rare when it comes to our solar system. Like, on any other planet you won't found water. And water is, as of now, water is available on our earth surface, and if you see from the space, this water will appear like a blue, and that's why our earth is also being called as blue planet. Now this blue color is because of the light phenomena. There is some sort of reflection, and we have a diffraction, scattering. Okay, because of that, if you see from space, our planet will appear like a blue, and that's how it got the same name with respect to the color. When it comes to our earth surface, so because of the abundant water availability, it is being known as blue planet. Yes, we have a one very much important aspect with the water, is that water can be used and water can be reused. Water is a cyclical resource. Cyclical resource means, like, when you utilize at each stage, that can be reutilized while following a particular process. So for example, let's say we have a sunlight, and when there is a sunlight in any water body, what will happen? There will be evaporation. When there is a evaporation, there will be a cloud formation. We have already discussed all of these things. Okay, so when there is a evaporation, when there is a cloud formation, after that there is a rainfall, and when we have a rainfall, some part of rainfall will seeps in ground, that is being known as groundwater, and remaining part will be there in water bodies or surface water bodies. That could be river, that could be lake, that could be pond, that could be dam as well. So when we have a surface water, now the surface water is same, subjected to some sort of evaporation. So this cycle keep on running. Okay, here for example, you have a evaporation, then you have a condensation, then you have a rainfall, then you have a runoff, and then in water bodies you will see that water is actually collected, accumulated. Some part is actually being there in the groundwater, which actually used on surface, and that could be evaporated. So basically what we can say, water is actually a cyclical resource. Now this cyclical representation of water is being referred as hydrological cycle. It is a hydrological cycle. Hydro means water, and there is some sort of cyclical movement of water, so hydrological cycle it is. Now in our contemporary world, if we see for example climate change, so because of the climate change, this evaporation lag is actually getting more and more faster, and it's because of that what we can say that the surface water bodies which are there on our earth surface, they are getting drier earlier than their usual pattern. Means suppose we have a water, okay, suppose we have a water, and this water temperature is 20 degrees Celsius. Okay, I'm just taking for a reference so that you will have a clarity that how this evaporation is getting faster in modern sense or in modern era of climate change. Let's say we have a 90-degree insolation, and because of that insolation, let's say in order to get evaporation, this liquid form of water, in order to transform or translate in terms of gaseous or water vapor, it requires some sort of 50-degree temperature. Now the surface temperature is 20 degree, and in order to get evaporation, temperature should be 50 degree. So this 30-degree gap which is here, that 30-degree gap is being fulfilled by the insolation which is there. That could take time. Okay, now we have a different situation here, and in this different situation, let's say you have a water, for example, you have a water for example here. Okay, and you have a same angle of insolation, but because of the climate change, what is happening, that the surface water temperature is somewhere, you can say 25 degrees Celsius, because of the increased temperature. Okay, because of the increased temperature, the surface water temperature is 25 degrees Celsius, and now we have a same thing, that in order to evaporate, this water should reach to the threshold temperature of 50 degree. Now here you can take a consideration that the gap was 30 degree here, and now the gap is 25 degree here. That means what? That means that in a one given day, for example, the amount of insolation which was there in the normal condition, that was able to convert the liquid droplets into water vapor, let's say 2 units. So here with the same time period, because of the insolation, because of this surface temperature which is actually increased, now here the evaporation will be 3 units. So what we can say, because of the climate change, this leg of evaporation is getting more and more faster. Now what will be the result of this faster leg of evaporation? The faster leg of evaporation will ultimately result into extreme weather events. So extreme weather events would be there on our earth surface, and you might have noticed those extreme weather events, that we have instances of flash flood, we have instances of unseasonal rainfall, you might have observed. And yes, you might have observed that there is also some sort of drought like conditions. It's because of the alteration in this hydrological cycle which is there in a normal phase. Because of the human induced anthropogenic action, this hydrological cycle is getting modified, and that is actually again intensifying this phenomena of climate change. Is getting more and more variable. Okay, all right, so that was about the idea with respect to the we can say hydrological cycle. Now moving ahead, like previously we have discussed that our earth surface, the surface or the continent which we used to see, that the continents are highly uneven. Continents have their own distinct topographical feature. Somewhere you will see that we have a plain, somewhere you will see that we have a gradual slope, somewhere you will see we have a steep slope in terms of mountains. Okay, sometimes I hope in landforms you might have covered that at a micro level or at a macro level, in what pattern the topography used to look like. And as per that particular pattern, we used to say that our continents have some sort of relief feature, continents have some sort of topographical features, means highly uneven surfaces are there. Now the question is, what about ocean? Do ocean have same kind of unevenness, or ocean have some sort of, let's say, the slope in such a way? Okay, and this is what filled with the water, that's how it is called as ocean, for example. And this is what called as continent. Like, do we have some sort of slope feature with the ocean? Yes, we have a huge diversity even in the ocean surface. Ocean bottom would be correct. At the ocean bottom you will see that we have a huge diversity. Even we have a diversity at the scale of diversity which we used to see on the continent areas. We have a same kind of diversity even at the ocean floor. Like, you will see everything. You will see gentle slope, you will see gradual slope, you will see series of ranges of hills which are being found in terms of mid-oceanic ridges. They are also there. Now, when it comes to the particular ocean, or let's say ocean bottom, or the topographical feature which are appearing on the ocean bottom, so those features are also the result of tectonism. Whenever you have an oceanic plate, and when this oceanic plate is subjected to some sort of convergence or divergence, there might be fractures, you may have a rift valleys, and you may have some sort of volcanic eruption even at the like a depth of sea. Even at the sea floor you will see that there are some sort of volcanic eruptions. You will see in this session, or in this session, that there are some sort of underground, underwater slope orientation as well, that somewhere slope is shallow, somewhere slope is having a some sort of deeper aspect with respect to the surface level of ocean. Somewhere you will see we have a steeper slopes. So these kind of, you can say, variation which are there, these variations are there in the ocean, we can say, at the foothill of ocean. The problem is that we can't see that because it is submerged under the water. Okay, so we have a limitations. What limitations are there? That when you go in water, after a certain depth you can't go beyond that. It's because of the water pressure which is there on you. I mean, in general manner, I would like to say in that way. You have learned that in our atmosphere, or with respect to the atmospheric pressure, I told you that you have some sort of pressure of air on you. So we have a same set of pressure if you go deeper in the water. So water will have some sort of force, for example. Okay, and that I'm referring in terms of water pressure which is there. So you cannot go beyond a certain depth. Okay, when it comes to the ocean. So because of that, like, we have some sort of I would say unclarity that what exactly is the relief feature of our ocean. But when it comes to the broad classification of our ocean, so we have these ocean topographical features. We have a very topographical features of our ocean, and I told you that these very topographical features are actually the result of plate tectonism. It is actually the result of volcanism. It is result of we can say erosion and sedimentation. All of these are the dynamic processes which actually modified the topographical features which are appeared on our surface. And yes, same features when they are appeared underwater, ocean. So yes, it is hidden beneath the water, but I told you that here we have a diverse form of landforms which are there in our oceans. So with respect to the topographical features, we used to differentiate ocean topographical features in two ways. That first, we have a major oceanic relief features, and then we have a minor oceanic relief feature. Minor means at a some sort of, we can say, where you have a low in terms of height, or when you have a low horizontal expansion. But when you have a major height wise expansion, and when you have a major horizontal expansion, so those features are under major oceanic relief, major oceanic slope features. And when you have a slow, or when you have a smaller, for example, so they are being known as minor oceanic relief or minor oceanic features. So you have a continental shelf, you have a continental slope, continental rise, abyssal plain, mid-oceanic ridges, and oceanic trenches. So these are the major oceanic relief features. When it comes to the minor oceanic relief features, so here you have a minor oceanic relief features which are actually there with respect to the submarine canyons, guyards, the seamounts, coral reef, and atoll. We will see that what are these. These are actually the topographical features. So you have to focus that what kind of relief features are there, whether it is like this, whether it is like this, whether it is like this, whether it's have a form in like this. You have to see slope, that how it used to look like. That is what the topography or relief. Moving ahead, now here you can see that that major ocean topographical features. Here you can see in this image. I'm getting out of the frame so that you can see this entire surfaces or the orientation of slope which used to look like. So here you can see that we have some sort of like shallow areas. Okay, you have this slope where you have a shallow slope, then you have a steep slope. Okay, then again you have for example a gradual slope and then steeper slopes. Then you will see a flat plains, and you will see that whenever you have these kind of low lying ridges or low lying hills, so they are the result of divergent plate boundary movement. I hope you remember. Okay, so here we have a mid-oceanic ridges. So tectonism is also deriving what the it is also adding some sort of dynamism to the ocean surface as well. So ocean surface is also dynamic, and because of the tectonic movements, there is a building, there is a destruction of the ocean crust as well, and accordingly you will see that because of the bending, because of the folding, because of the wrapping, because of the down wrapping, for example, you have these kind of topographical features. Okay, here you can see that we have a trench. So I hope you remember with respect to the plate tectonics, we have discussed that wherever you have two plates, when they are meeting with each other, that is what the portion which is being known as trench. All right. So first here, if you see, for example, so this is the very first, we can say, continental shelf. So continental shelf is I mean, you might have there on the beaches. Okay, and when you are on beach, you might have observed that there is a gradual declining of that particular slope, and now that region is being called as continental shelf. Okay, that region is being called as what? Continental shelf. It is a part of continental plate. Okay, it is a part of continental plate which is actually submerged underwater. It's a part of continental plate. Okay, it is not a part of oceanic plate. So continental shelf, continental slope, both are actually the part of continental plate, but they are submerged underwater. Okay, if they are submerged underwater, that doesn't means that that is the oceanic plate. No, continental shelf, continental slope, they are the part of continental plate. Okay, so whenever you have this shallow water, if you are standing here, so you will see that there is a gradual like a slope, and this slope will have some sort of 1 to 2 degree elevation. So when you have this elevation and when you have a gradual slope, that is being known as what? Continental shelf. So it is a gradually sloping area. Then you will see that we have a one particular, I would say, a shelf break point. Now shelf break point is a zone, or let's say you can say a particular point from which now the orientation of ocean slope is about to get changed. So here, instead of gradual, now it's become what? Steeper. Okay, so when you have this steeper slope, so steeper slopes means what? Steeper slopes means it is a continental slope. Okay, then we have some sort of gradual slope here. Again you can see, so that is being known as continental rise. I'll tell you and we'll have a deep overview on these all. Okay, then here you can see that we have a oceanic crust, and wherever you have a divergent plate boundary movement, the oceanic crust is actually split into two, and that is how it is being there. So from here, for example, we have a commencing, or we have a beginning of ocean plate. So we have a mid-oceanic ridges, and here you can see we have a low-lying hills, and these low-lying hills are actually being there because of the symmetrical like a deposition of lava which is actually taking place because of the divergent which is actually taking place in between these mid-oceanic ridges. Then suppose we have a volcanic eruption, and when you have a volcanic eruption, and for example, and that volcanic eruption, if it is like this way, for example, so they are being referred as volcanic mountains. If you have a mountains, these are basically referred as seamount, you can say. And when you have a appearance of this particular, we can say, seamount, if it is above the sea level, so that can be referred as volcanic island, for example. So here you can see we have a volcanic island. Okay, so this is how we have a different form of topographical features. More topographical features we are about to see. So let's see all of these topographical features one by one and with a more broad overview. Before that, let's complete, or let's cover this particular minor topographical feature. So minor topographical feature, here you can see, for example, we have a coastal plains, then we have a continental shelf. Here you can see there is a shallow water, okay, and there is a gradual slope. Then you have a continental slope. Okay, after the continental slope you have a abyssal plain. Abyssal plain means deep plains, you can say, deep plains, or in which the mid-oceanic ridges were actually being found. However, those ridges have some sort of this kind of elevation, so can't be called as plains, because plains means what? Flat areas. Okay, but in those flat areas in between we have a mid-oceanic ridges, like the we can say conical shape of hills are actually being there. So that particular region is being known as mid-oceanic ridges. However, that region is in that particular abyssal plain, which is actually being there here. Now, when the water is there, see guys, when the water is there, for example, rivers are there, and these rivers are running from the mountain, and when they will discharge, or when they will form delta while contributing their water, or while releasing their water in ocean, so what would happen, that there is some sort of velocity, okay, because this water is actually following the slope, and while following the slope some sort of energy is there, and because of this energy, when this water is entering into the continental shelf area, it will perform what? It will perform erosion. And here, while following the slope, like there is a vertical down cutting, and this vertical down cutting is being referred as what? This vertical down cutting is being referred as submarine canyon. Here you have a canyon. Okay, so this is the example of canyon. So when you have a cave formation because of the running water, vertical down cutting, this phenomena is there. When you have this phenomena, this is being called as, this phenomena is being called as what? Canyon. So this is canyon actually. Okay, then you will see that we have a seamount. So seamount is what? Underwater mountain like structure. And what is guyot? Guyot means when you have a flat top. So when you have a flat top, this is what actually guyot. What happens, that if this particular seamount height is rising, so that can be resulted into volcanic island. So this is appears like over the surface, I mean above the sea level. So from the top, if you see, so it will look like that there is some island. However, like at the base it is volcanic, you can say. And when it is eroded, lastly, that can be guyot. Here you can see in this image that we have a corals. These corals are actually colorful. Okay, beautiful colors are there in the corals. I mean, how these are there? Because we have a coral polyps, and you will get to know that there is a coral bleaching, and because of the coral bleaching, now these are actually being deteriorated, they are degraded, and that is actually a concern for the ocean or the marine resources, about which we will have a deep dive later. As of now, we are just having an overview. So here you can see, for example, this is for the volcanic island. Because of the volcanic eruption, its height is getting increased, and from the surface it will look like this. And if there is an eruption again, so it might be getting more and more broader. So this is what the sectional view, this is the top view. Now what happened, that when this particular volcanic island is there, now this volcanic island, if there are coral polyps, they will have some sort of their colonies. They are very small tiny animals. Coral polyps are very small tiny animals, and what they used to do, they used to extract the calcium from the sea water, and their skeletons are comprised of what? Mainly the calcium carbonate. So when they die, like they will be here, for example, okay, here, because they will able to survive in the photic zones. Photic zone means up to a certain depth. Photic zone means from the surface to almost 200 meter. That is the portion of water which can be penetrated by the sunlight, and that is available for that sunlight is available for the planktons, or let's say the plants which are available, which are there in the top surface water, so that there can be a dissolved oxygen over which fishes and the other marine organisms which are there, they can survive. So when we have a coral polyps, so if the coral polyps are like this, for example, so this will be known as fringing reef. if we have a further some sort of, we can say, uh, if you have a further upliftment, for example, further upliftment of these barriers, or let's say these corals, so this is being referred as this kind of situation. Okay, so it is being called as barrier reef. We'll have a more detailed overview about this. Okay, don't worry, coral and coral bleaching is a separate topic in our oceanography, so we'll have a detailed deep dive on this. Okay, as of now I'm just giving you overview. So that's how the water bodies are there, and they are being known as lagoon. Then we have atolls, means like we have a this entire volcanic portion which is actually not sinking, but you can say because of the increasing height of this, it appears that it is actually sinking. All right, so you will see that we have these corals specifically. Now let's have a deep dive on each and every aspect which we have discussed. As of now, we just got some sort of orientation idea. Now we will be discussing with respect to the deep, or with respect to the deep dive over the major relief features of ocean. And among them, we first of all we have a continental shelf. Continental shelf is a, you can see here in diagram that it is the portion which is interacting with the land part, and it is the portion which is interacting with the water, or let's say sea part as well. However, I told you that the continental shelf is a part of continental plate. Now when it comes to the continental shelf, so continental shelf, so this continental shelf is basically what? A shallow gentle slope which is submerged, and this continental shelf is basically nothing but the extension of continent, and that extension of continent which is actually submerged under water. Okay, so the average elevation of this continental shelf will be to some extent 1 to 2 degree, okay, roughly. Okay, and it will have some sort of shallow water, and it could be broader, okay, and it could be narrower based on the location of this particular shelf. And yeah, here when it comes to the like portion of continental shelf, so continental shelf is a main aspect where you can see that after that, for example, steep oceanic slope will begin after the continental shelf. Here you will see that we have a shelf break point. After the shelf break point, there will be a steeper slope which is being known as continental slope. However, we'll restrict to the continental shelf as of now. So this continental shelf is basically a, we can say, the middle area or transition area between the coastline and the continental slope. Okay, so it is a transition area between coastline and shelf break point, or you can say continental slope areas. It is basically the true underwater edge of continents. Okay, so that is why the name is there accordingly, continental shelf. Now average depth of this continental shelf is ranging roughly from 0 to 200 meter, means the depth, we are talking about depth. So here, for example, 0, and lastly, like the broader extension, up to a broader extension, it could be deeper, roughly, for example, 200 meter. That much depth is there. However, when it comes to the length, when it comes to the extension of this particular continental shelf, it could be extended up to the hundreds of kilometers, and it could be narrow up to few kilometers. Okay, so beyond this depth, seafloor is suddenly steepened, and that is what the shelf break point, which is actually being observed. Thereafter, there is a beginning of continental slope, and less than 1, but you can say roughly from 1 to 2 degree. This is what variation, rough variation. Okay, somewhere you will see 1 degree, somewhere you will see 2 degree, even somewhere you will see less than 1 degree as well. So that is correct. Like for a global reference, if you see, so for example, some continental shelf will show you some sort of less than 1 degree continental shelf angle with respect to the coastline. Some will show 1 degree, some will show 2 degrees. So less than 1 or 1 to 2 degree, there is need not to worry, it is not wrong. Geography, I told you, there is nothing exact. All right, it is composed of continental crust rather than the oceanic. I also told you about this thing. And the width of continental shelf varies hugely. It varies because of the tectonic setting, it varies because of the sediment supply, and it is also vary because of the sea level change. See guys, in what way you could have an alteration when it comes to the water which is here in with respect to the continental shelf. See, if a river is there, and if this river is broughting so many sediments, and if these sediments are keep on deposit here, so what we can say that this continental shelf is getting more and more shallower with respect to the water level. Suppose this is the sea level, okay, this is the sea level, and like because of the deposition of sediments, what you can say, this is what the normal level, or let's say this is what the normal elevation of continental shelf. Because of the keep on deposition, for example, what can be there, because of the keep on deposition, here you can see, for example, that now the water is getting more and more shallower. So this aspect could be there when you have a more and more sediment supply which is actually being done by the rivers. First thing. Second thing is that sometimes there might be a possibility that because of the movement in this oceanic crust, we might have some sort of bending of this continental crust. Okay, so in that case, when the continental crust is bending, there might be a possibility that it may break from this side. Okay, so in that case, continental shelf could be less wider, and it could be some sort of have a adjustment with respect to its depthness, that what extent there is a gap between the sea level and the depth of continental shelf. So we have a two ways in which there could be an alteration in the depth of continental shelf, or let's say the gap which is there between the sea level and continental shelf, that could be subjected to alteration by these two aspects, sedimentation and tectonism. And yes, sometimes because, or let's say because of the contemporary times, you can say climate change is a reality because of the more sea water which is available. So what we can say, that there might be a possibility that the sea level may rise, and if the sea level may rise, what we can say, there is a direct impact on the depth of water which is available on this continental shelf. So what we can say, that the continental shelf and its depth of water is subjected to change over the period of time because of these three important factors. Moving ahead. Now, when it comes to the continental shelf, so continental shelf could be, for example, 20 kilometer. Even continental shelf could be, for example, somewhere 1500 kilometer. Okay, so this is what the length actually. Somewhere you will see, for example, 20 kilometer length, somewhere you will see 1500 kilometer length. It is like based on the particular Siberian shelf. If you see Siberian shelf, so the Siberian shelf is actually widest 1500 kilometer. That is what the length. Okay, yes, it is submerged underwater, perhaps covered with the ice caps, but its length would be from 0 to almost 1500 kilometer. And yes, the depth is also same with respect to 0 to 200 meter depth, I am telling. Okay, it's because of the massive river sediments input. Because of the sediments input, the continental crust is more wider there, and there is a tectonic stability with respect to this particular Siberian shelf. That's why you will see that it is widest. When you see Atlantic continental margin, so they are also have some sort of wide continental shelf extended up to 1500 kilometer. But when you see the western coast of South America, you will see that the continental shelf is very much narrow. You have a 20 to 50 kilometer. That is what the length of continental shelf. So what actually controls the length of continental shelf? The length of continental shelf is actually being controlled with respect to the tectonic activity. Okay, the length of continental shelf is actually being controlled with respect to, for example, the terrigenous sediments. I mean the sediments which are actually coming from the surface. They are also the one who are actually covering the depth angle of water. And when we have a river, for example, I told you they brought these elements, and as of the sediments, you could have a sediment thickness which could be there with respect to the seaward. If you move seaward, so the thickness used to be increase when it comes to the sediments which are actually being brought by rivers. So we have these things specifically. See guys, when it comes to these two aspect of wider, or let's say more length in continental shelf, and here you have a less length in the continental shelf, it's because of their position. It's because of the active and the passive margin which are actually the result of we can say